What you see here is a model of a harbour tugboat built by Aquacraft. The Atlantic comes fully assembled with a 2-channel remote control. I'm not interested to build a model like this. However, I am interested in the electronic controls of the boat. My name is Armin Umhang and I'm going to show you how I made a simple bridge simulator. First, we need a steering wheel. The setup can be seen here. On top of the box is a reset button that resets the microprocessor and brings the rudder into its center position. On the right side is the RS-232 connector linked to the computer. The bottom connector is the power supply. Attached to the shaft end is a Burns 2-bit 128 cycle rotary encoder. The pulses get processed by a PIC 18F2550 processor, then are transmitted over the RS-232 link to the control computer. I'm using an off-the-shelf processor board and the student version of PIC Basic Pro to program the microprocessor. The onboard control is also done with the PIC 18F2550 and an off-the-shelf processor board, the same as in the steering wheel control box. There are 2 batteries, one placed on each side of the boat. One supplies power to the microprocessors, data transceiver, video camera, transmitter, GPS module, lights and horn. The second battery is the power for the motor only. On the left you can see a Vero board where the low voltage detection circuits are mounted for the 2 batteries. There is also a small PIC 12F675 processor module attached for the speed control, programmed with smooth ramp up and ramp down of the motor. It is also programmed with the student version of PIC Basic Pro. Behind the bridge window is the camera. On the back wall you can see the data transceiver with the antenna on top, and on the floor of the bridge is the GPS module. Okay, here's my control, or bridge simulator if you want to call it like that. I'm using here an Asus PT2001. It's an all-in-one computer with a glare filter fitted, 19.5 inch, and it's working quite alright early mornings and later afternoons outside in the sun. The program starts up and shows me that port 1 is open and shows me port 2 is open. On top here we have got the local time, we have got the date. UTC is not listed because I'm not going overseas with the boat, so UTC is not important here. Here on the left we display the data that comes in from the GPS. That's the latitude, the longitude, heading, compass and the speed in knots and kilometers. Here is the camera, works quite well. Here we go. And I can switch that over to the C chart. The chart is a static chart. It is calibrated on the edge here and here, and with that I can display the position of the boat accurately on the lake in here. The autopilot settings doesn't work, I haven't programmed that yet. Here is the rudder position. That's important to know, because when you start the boat you want to know what direction it's gonna take. I turn the steering wheel and we can see how it responds. Here is the lights, the navigation lights on and off. We have got a horn. That works. It's not very effective in the open, but it does work. Here we have the engine control. In the old days it was called engine telegraph. Now is everything digital. We can go dead slow. We can slow ahead. We can go half ahead. We can go full ahead. And the motor ramps up and down quite nicely, programmed beautifully. We stop it, we can go astern if we need to reverse. That's fine, and that's the control of the engine. Here is a data monitor, that's more for myself. If something goes wrong, I can check whether I actually get the data in or whether it is a problem with the software. Here is the raw data from the GPS. You can see it changing. It will not display because I'm under the metal roof here and the signal cannot be received from the satellites. Here is the data from the rudder. I change it and you can see the rudder position changes with it accordingly. Here is the GPS reset button. Should something go wrong, I can reset the GPS and it will start working again with its new data, or refreshed data rather, and give me all the data back from the boat. Here is the raw data that comes in from the GPS and then is converted and displayed in the latitude, longitude and all the data displayed what is needed. We have safety features like low battery status. I disconnect the battery in this case and in 30 seconds I will have an alarm coming up. Normally it would be just a low battery status and I can acknowledge it and come back to port safely without losing the boat or going for a swim. The same is for the control voltage for the microprocessor on the boat. When the battery goes low, it gives me an alarm. I can take the boat back safely. I will have enough juice in the battery to come back to port and change the battery. Should I have a problem with the computer, a software hang up or losing power or whatever might happen, the boat will stop within 5 seconds of communication loss. It will stop, wait until I establish communication and I can take control of the boat again. That is the control of the boat and we will see how that works in practice. The power supply is a 300 watt, 12 to 240 volt inverter and is alright to run the ASUS all-in-one computer, the data transceiver and the video receiver. I had the boat in the water well over an hour and all batteries were holding up beautifully. The car didn't need a jump start either. To power all the equipment, I need a portable power distribution box. You can see the data transceiver on top, below is the video receiver. There is the power board to plug in the power packs, including the one for the steering wheel to supply power to the microprocessor. On the front is the power point to plug in the computer. Here is the whole setup, waiting for a helmsman. Looks like somebody is having fun here.
I want you to go this way. Okay, press. Now, good. Now he's gonna go.
He's turning.
That is wonderful. Wonderful.
Thank you very much for watching this video.